Okay, so we are actually going to be, we're just kind of sliding into home right now. We got 3 lessons that I think should be quite easy compared to the ones that we've done. This one is actually going to be all review with just changing some words to fit trig. Okay? Now, these 2 formulas you should be very familiar with by the time you get to the exam, okay? A sine B x minus c plus d. So A and B we have dealt with already. A stretches it and affects the amplitude. B stretches it horizontally in and out, which affects what? When you stretch it horizontally, what does it affect? The period and the x-intercepts. Okay? When you pull it this way, do you affect the x-intercepts? When you pull it up and down? No, you do not. It's like it's attached there and you're just pulling it, okay? So it only affects the amplitude. But now what we're going to do is we're going to pull it both directions, and then after we're done, we're going to slide it left and right and up and down. Okay? So that is your horizontal and vertical translations, which are going to be called different names today. They're going to be called horizontal phase shift, and a vertical translation will now be called a vertical displacement. Okay? So, new words to know that are very specific to trig. Now, horizontal phase shift will only be in radians or degrees, and vertical displacement will be in units. So you're always going to have to say a horizontal phase shift, 3 radians right or left, or degrees right or left. We're not going to say units. And we will say units for vertical displacement. Okay? So what we're going to do is just turn to the next page. So let's go down to the chart. The chart sums up everything that you need to know. Now, so sine and cos, A is max minus min over 2, or amplitude. Period is done by 2 pi divided by B. Horizontal phase shift is when we have C greater than 0 or less than 0. It's going to move right when C is greater than 0. Now remember, we're talking about the number after the minus sign. So x minus 3 is actually a positive 3, right? Because we're looking for the number after the minus sign. Now, these rules actually fall that if you bring this to this side, then if d is greater than 0, it moves up. If it's less than 0, it moves down. Okay? So that is totally review. And the only thing we've got to keep an eye on for tan is make sure we know it has no amplitude. The period is 180 divided by, and pi divided by, and vertical and horizontal phase shift are the same thing as sine or cos. Okay, so let's go right to doing some of these. We're going to do 2 questions. We're going to do B on both of these. Okay, now what we first want to do is go to what we've always known, and that is getting the y's with the y's, the x's with the x's. Okay? Now, what is the first step here? Because often some people are making this mistake. How do I get this first? What's the first thing I'm going to do to get the y's with the y's? Algebraically. Minus 3. What do you think is the wrong step that is happening too much? Yeah, they're doing the 2 over 3 first. Don't do the 2 over 3 first. So if you see why this actually works well, so you get that, right? Then we will multiply both sides by negative 3 over 2. Now, if you go back to some of the first unit, there's a question just like this in there, except the coast would have been in degrees because students would have been able to not do the radians. But it's everything we've always done. Now, it asks for, first of all, the amplitude, which is A. What is the amplitude of this equation, this graph? 3 over 2? 2/3, right? Remember, it is the vertical stretch. See, what's the vertical stretch of this? It's a vertical stretch by 2/3. Or you could just take your A value. So, two wrong answers are 3 over 2. And what is the other wrong answer that I'm going to get a lot of? Negative. Do you have a negative stretch? No, the negative deals with the reflection. And this came up a lot in the other class, is like, why aren't we dealing with this? Well, we will later, but they didn't ask for it. They asked for the amplitude, the period, the horizontal phase shift, and the vertical displacement. They did not ask anything else. So just give them what they want, and the rest we'll do later. Now, the period, how do you find the period? Anyone remember the formula? 2 pi divided by b. So that would be 2 pi divided by 1/4, which is the same thing as 2 pi times 4 over 1. So 8 pi is actually the period. See, this has a vertical stretch, or horizontal stretch by 4, right? So it was 2 pi, so if I vertically stretch it by 4, it's going to be 8 pi. It's going to be the new period. The next thing they want is C. So I've done A, I've done, this is B, right? Oh, sorry, that's period. What am I talking about? That's period. Okay, so I got my period done. What would be my C? What is C? Okay, pi over 12. So what does it really mean, though? What does... I can't just put pi over 12 for C. It has to be, we have to describe the translation. It is a... Yeah, it is a... What type of... So really, I should be saying, it's a horizontal phase shift pi over 12 radians right. That's the new way we have to say it, okay? It's complicated, but it's trig. It's just saying it in a trig language. Okay? And then D is the vertical. Vertical what? What is it called when we move it in up and down? Displacement. Good. And you can remember D with displacement, right? So D is a vertical displacement it would be 3 units on down, which would be up, right? Because it is a positive following a, right? Because it's a positive. Okay. Now, B, let's not go through the whole thing. What do you think B is trying to catch on? Factoring out the 2, right? Now, one thing that is going to make you furious when you walk out of that diploma is if you get caught on one of these. Okay? When you get in the little discussion when you come out, and somebody says, hey, for number 18, did you take out the 2? And you're just like, no. Oh, we did tons of those in class, right? So that's the stuff that you get mad at, especially if you left early. You left early and you didn't even check those things over. Okay? And there's ways to catch that by graphing, but you have to go into the diploma being kind of, a little bit on a higher level of sensitivity of seeing all those little things, okay? So always make sure we're getting the habit of that. Okay, now this next one, we are looking at, give me the equation to the right in a sine x minus c. So in other words, there is no horizontal stretch or vertical displacement. Now, what I like to do all the time on these, it helps me a lot, is actually draw what sine x would look like. Now, sine x, remember, it starts at 0, it goes to, now this is 1, you can see by their increments here. This goes to, and it goes through there, then it goes through there, and up, okay? Now this is sine x. Now, why do I care about that? Well, I think it's always relevant, if you're going from here to there, to know where here is. If you don't know that, you can't even tell how far it moved, or how it was stretched, or whatever, right? So I think it's very hard to do without the original. Now, remember, we still want to be thinking in the terms SRT. Now, how do I know this didn't move up or down? Well, what's the midline of my original graph? That's the midline of my original. Is that same midline of the after? Yes. See, the way the midline moves is how I know my vertical displacement. I stay away from the top and the bottom. I don't care about that. How did the middle move? So the first thing I do is go, I can see why there's no vertical displacement on this one. Now, we're going to do a stretch first. Now, what do you think the stretch was? By how much? It was stretched by 4. So the next thing it should look like if I stretch it by 4 is it should look like this, right? So I know my vertical stretch, or my A, should equal 4. Now, it says A has to be greater than 0. Okay, well good. A is greater than 0. I'm all good. Now what do you think happened to get it onto... Okay, does everybody see what I'm doing? I want to see how far to get it onto... Why are you not moving? God. Oh, that's weird. Oh, there it goes. Okay, so it was there. How far am I going to get it to here? Not 2. Does everybody see that this does not go 1, 2, 3, 4, 5? Right? So you can't say 2. How does this go? By what? So that is a challenge that you have to now work with. Here's how I do it. I find pi. Do you see where pi is? And I say, well, how many things made up pi? How many things made up pi? 6. So that is pi over 6. Okay? So always find your increments. Now here they are, pi over 6. And you can tell that's 1 pi over 6, 2, all the way to 6 pi over 6. 6 pi over 6 is pi. So if you know your increments, how many of them did I move right? 2 pi over 6. So we did 2 pi over 6 right. Now, do you think they're going to have 2 pi over 6 on the answer? They're going to have pi over 3 right, okay? So the equation is now y equals 4 sine pi Plus or minus? Minus pi over 3. That is that graph. Just making sense. Okay? What are things that you're just expected to know? You're expected to know what a sine graph looks like originally, and you're expected to know how to find the increments. It will not tell them to you directly. But find where pi is. If there's 3, then they're all pi over 3s. If there's 12 in between 0 and pi, then they're going, right? How many? It'd be 12 pi over 12 would be the last one, right? So it'd be pi over 12. Okay? Now, they're putting a twist on this one. They said, what would be the equation if a had to be less than 0? So what are they saying? A is negative. So if a is negative, what is that saying in mathematical language? It's less than 1, but it is a reflection on the x-axis. Okay, so you can see why this is a really good unit to have last, right? Because lots to know in trig, but it reviews my entire first unit. And that's pretty nice, because that is 3 units you should know perfectly going into the diploma without having to put a lot of time into it. Okay? Now, here's what had to happen to get this one. Now, again, what does the original look like? Draw it in there. Oops. I'm getting ahead of myself. Okay, this is the original. Then, we were told we need to reflect this. So this is reflected. Then it is stretched by 4. So it's going to look kind of like this. Now, the goal is to get, now what happened to get that on top of that final graph? What is it? Yeah, horizontal phase shift. 2 pi over 3? How are you getting that? But look, 1, 2, 3, 4, 5, 6, 7, 8. Very good. Okay. See, how did I know not to go that way? It says, what is the minimal possible you would move to get this on here? And you should be going 1, 2, 3, 4 pi over 6s, right? So we know if a has to be negative, then I got my negative 4 done, and then a horizontal phase shift 4 pi over 6, which is 2 pi over 3 radians left. So what's the new equation? Y equals negative 4 sine x plus 2 pi over 3. So these two I have proven are identical graphs, right? So how would I make this into a question? I would just say y equals 4 sine x minus 3 is equal to, and I would have A, B, C, or D. Okay? So, again, a good question, I think, if you're a teacher. Probably maybe not a good one if you're a student. But sure, you got to know a lot of stuff to do this one. Now, speaking of, you got to know a lot of stuff. This is the kind of question that if you have it shown up for class, good luck. It wants the equation of that graph. Okay? Now, again, we are doing a sine graph, and it says, I want a to be greater than 0. So it says fill in the chart and then give the equation. Okay? So you're going to come up with the equation of this thing. So, two things that I would do before I even started was, first of all, I would find the increments. What are the increments? So again, look at here, at pi. What are the increments? Talk to me, guys, or I'll turn the heat down even more. Don't make me do it. Pi over 3. Because that's 3 pi over 3, right? See, everybody, this is 3 pi over 3, right? So this must be 1, 2 pi over 3, 3 pi over 3. The next thing I do is draw the sine graph. Now, this one's going to look a little bit weirder because look where 1 is, right? So it's going to look like this. Comes down here. And about right there. So you're going, well, how come the line looks so different? Well, look at how 1 is spaced out. Like they're going by 0.3s, which is just weird. But you never do that, by the way. If you ever have to draw a graph, don't go by 0.3s. So that's what it was. Now it became this thing. Now, these can get really out of hand if you don't get your bearings. The best way to get your bearings is by doing midlines. They will help you tons. So this was the original midline. Where's the new midline? -2. Very good. Now, what does that do for me? It does a lot for me because, number one, it tells me exactly how much that graph moved up or down. If you actually try to look at the tops and bottoms of it and try and figure it out, you won't probably get it. Okay? Now, with that midline, it tells me a lot of good stuff. The first thing that I realize is now I know what the amplitude is. The other thing that I know is I know how much it's moved left or right. Because do you see, when you stretch things, I want you to look at this original graph. When you vertically stretch it, will this move? When you horizontally stretch it, will this move? So look here, there was a vertical stretch, then a horizontal stretch, then what happened? There was a vertical displacement and then a horizontal phase shift left. Why do I know that? Well, look, it's 1 away from the y-axis. So I can get all of that by drawing my midline in. It gives you a lot of bearings. Okay? So, yes, I have not even started, but I figured out a lot just by doing this. So if you want, I guess, the steps, get the increments, draw sine x, draw the two midlines. So what's the amplitude? Well, the amplitude, I can do two ways. I can actually visually look, and I can see that my amplitude is 4. Or I could do, 3. Or I could do max minus min all divided by 2, which is also 3. No, he was in first class. So, are you looking for your brother? No. Sure. I was going to give you up, but I was very specific about his landings. So, you can look at it visually, or you can use the calculation max minus min over 2. The period is, what you want to do is actually go from the midline again, okay? Midline to midline. So the period would be that right there. So count them. How many pi over 3s is it? 12 pi over 3s, right? So it is 12 pi over 3, which equals 4 pi. That's the period. What is the horizontal phase shift? Now, I think it's easy to do vertical phase shift, vertical displacement, I should say. What's the new vertical displacement? How much did the midline move? Minus 2. Or you could do max plus min over 2. And that gives you the answer, negative 2. So, amplitude is max minus min. Vertical displacement is max plus min. So, it's like a average, right? It's the middle, the average. We always add numbers together when you find the average. And then the phase shift, look how far it's moved from the y-axis. It has moved pi over 3 left. Okay, now we really haven't got any marks yet. If this was a multiple choice, I don't even get any marks. I actually have to come up with the equation of this thing. Now, remember, I need A, B, C, and D. A is the amplitude. So A is 3. How do you find B? Does anyone remember? I can hear it. Yep, so B equals 2 pi over P, which is 2 pi over 4 pi, which equals 1/2. And then my C is negative pi over 3, right? And D is negative 2. So my equation is y equals 3 sine 1/2 times x plus pi over 3 minus 2. Because remember, this is supposed to be like a minus minus. And remember, this was a y plus 2. Right? So when it comes to the other side. So getting that equation without knowing how to do your transformation is going to be tough. Yep.
How do you figure out the horizontal phase shift again?
How far did it go from the y-axis? Which is 1 pi over 3 left. Okay. Now, how would you do this if A had to be less than 0? So in other words, it was stretched, then flipped, then moved down, then moved left or right. Now, after it was stretched and flipped, it would look like this. Okay, so I'm getting a little lost here. Okay, but anyway, I got this bottom part that makes the most sense here. Okay, so this is after it was stretched, flipped, and then moved down. So what is the minimum phase shift this would have to go? Now, should I go left or right? If I go right, it'll be, come on, maybe. We can do this. 1, 2, 3, 4, 5. Okay? Now, if we go the other way, it'll be 1, 2, 3, 4, 5, 6, 7. So we talk about minimum. Minimum phase shift would be 5 pi over 3 right. Okay? So we would get y equals negative 3 sine 1/2 times x minus pi 5 pi over 3 all minus 2. So remember, these are the same. Okay, let's go to pure theory. So no numbers at all. What I want to know is how do you, what changes domain, range, amplitude, period, zeros, okay? So we're just going to talk about these two equations. And we're going to talk about A, B, C, and D. Now, again, it's always kind of important to know, well, what does sine x look like? And sine x kind of looks like this, right? Goes kind of in both directions. Again, I don't have to get too fancy. And cos x does this. Okay, that's the difference between them two. Actually, you probably noticed that it's just a horizontal phase shift of each other. One could fall on top of the other if you moved one right or left. Now, A is the amplitude, right? Does stretching it this way affect the domain? It's going on forever anyway. If you stretch it up and down, so basically this would just kind of turn into this, right? So it does not affect the domain. So how about stretching it this way? Does it affect the domain? If it was the reals and I stretched it, would I get any more? No. Okay, so stretching it that way doesn't do anything. How about if I move it left or right? So I want you to picture that big thing. If I moved it left or right, does it affect the domain? It's going on forever in both directions. Does it affect if I move left or right? No. How about if I move that up and down? That entire graph, I move it up and down. So none of those affect the domain, right? Okay, think about it just for like 10 seconds. Just think about range. Which one or none of them or all of them will affect the range? Okay, any suggestions? A and D? Well, A definitely affects the range, okay, because it's 1 and negative 1 right now. Why would D? Because you're moving it down, right? Or up. So that obviously, which one of those affects the amplitude? Just A, right? Which one of those affects the period? B. Which one of those affects the zeros? Okay, does A affect the zeros? How about B? Yeah, B affects them. How about C? If I move that thing left or right? Yep. How about D? If I take that thing and I move it down? This actually isn't the right answer. Okay? Now, just humor me for a second. I want you to check this. If I had this graph and I stretched it vertically, does it affect the x-intercepts? Okay? What about if I had this graph and I did a vertical stretch on it? would it affect the x-intercepts? I would actually get x-intercepts, wouldn't I? So the true answer is all of those and A if D does not equal 0. So if that thing is anywhere else and I do a stretch on it, I do affect the zeros. So what I'm trying to say is, say I had this, I did my vertical stretch, and then I moved it, I think I've affected the zeros, have I not? So, tricky. Now, here's another good question. Just using these letters, tell me how to find the maximum and minimum values of a graph. You're only allowed to use A, B, C, and D. Come up with an equation that would give you basically the range. Anyone got any ideas? Well, which one of those affects the range? Amplitude. And what else? D. Now, do you see, if I had to, and I wanted to, I'm just going to talk about this one here. If I wanted to find the domain and range, or sorry, the range of this and this, so if I had the midline, what would I need to find the top? What would they have to give me? Amplitude. So do you see, if this is D and that's A, how do you find the max? This is A, right? And that's D. How would you find the max? Okay, let's throw some numbers in here. If this was -3 and this is 2, what is the maximum value? -1, is it not? So what I'm trying to do is get you to come up with a general equation. What would it be? I put numbers in there, you could get it. Now I got letters in there and it's silent. Yep. Or, I think better, D plus A, and how do I find the minimum? D minus A. Okay, so how do you find the max? Go D plus A. And how do you find the min? D minus A. Now, the book gives the formula like this: A plus D and -A plus D. I don't think that makes as much sense. But this, I got my midline, I'll add D and I'll add A and I'll subtract A from it. Okay? So how would you find the range of this function? If this is A and this is D, so just to give you a visual, I got something that has a midline of -4. That's -4, and it is going up 3, down 3, up 3, down 3, up, right? So this is a distance of 3. So what would be the maximum value? What would be the maximum value of my range? So it's going from -1 to, what's the minimum of my range? -7. So you just use your D plus A and D minus A. D plus A, that's -4 plus 3 equals -1. And D minus A is -4 minus 3, which is -7. Okay, so then I would say it is -7, -1. Thank you. Okay, so just do 1, A, C, E, dot, 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 and then 2 to 12, right?